glad you're here. And so, Christine, um, what I'm going to end up doing right now is I'm going to pull a problem from each of the four sections from chapter 5. So, y'all, and then Christine, if you have any specific questions that you want me to go over, please let me know. But I am going to answer one out of each of the four sections. And then, Christine, if there's any problems in particular that you want me to address out of either 5.3 or 5.4, then I will definitely answer those as well. Okay, so let me
Is
do.
it possible out of if you're going to do a couple from each one, can we do 11 or 12 in 5.1?
Yes, let's do 11 or 12. Okay, let me pull that up real quick. So this was 15. Let me get to 11 or 12. So here's 11. Yes, let me do this one first. So let me copy and paste this one here. Okay, and so let me minimize that, copy here. Okay, so okay, so now that I have this here, let me share my screen with you guys. You can see what I'm looking at. So all I did here, y'all, I just copied and pasted the problem into my notes. And so what I'm going to do here, let's see if we can't make sense out of this problem. Here we go. Let me get my pen. Okay, so it says a standardized exams test scores are normally distributed. In a recent year, the mean test score was 1544. Okay, so the first thing I'm going to do, I'm going to write that down. My population mean test score was 1544, and our standard deviation was 313. The test scores for four students selected at random are 1920, 1310, 2230, and 1430. Find the z-scores that correspond to each value and determine whether those values are unusual. Okay, so we're going to do this part right here for 1920. So remember, the way we're going to find our z-scores, we're going to take x minus mu over sigma. So my x in this case is going to be my 1920. So I'm going to take 1920 minus 1544, and we're going to divide that by 313. So y'all, on your calculator, you want to make sure that you put that part in parentheses, okay? So I'm going to try something real quick. Let me see. Instead of just sharing that, I'm going to try sharing my entire screen and see if this is going to work. Eric, you're here too. Excellent. Glad you're here. Okay, so that looks really weird, but I think this is now working. Yes, it is. Okay, so let me pull up my calculator so we can figure out how we're going to do this. Okay, and y'all, just one thing I wanted to mention, whether I'm using this calculator here or my app, I'm going to do it exactly the same way. Okay, so I got it on. Let's get my parentheses. So 1920 minus 1544. Oops, 1544. And then we're going to divide that by 313. And so the number I'm coming up with is 1 point, and I'm supposed to be going to two decimal places, so I'd say 1.20. Okay, hold on, y'all. Oh. I got a little bit of a head cold thing. So
Bless you.
thank you, appreciate it. Okay, so we got this first one here. There's my z-score. So y'all, what I'm going to do now is, let me see, I'm going to pull this part up here. I think you guys can still see this too. Yeah, it looks like it. And so right here, I'm just going to put in 1.20. And we got it. Okay. All right, let's do the same thing for the next one. So the process, y'all, is going to be the same. So now we're going to do it for 1320. So B, the x value we have is 1320. And so I'm going to do the same thing here. I'm going to say, I'm going to use this formula, and I'm going to put this in parentheses, 1320 minus 1544 all over 313. Let me grab my calculator again. So one way I can do this, y'all, is on your calculator, if you hit second and then the enter button, it gives you exactly what you typed in before. It works the same way on the app. And so I'm going to put 1320 because that's the number that I have now right here. Or is it 13? 1310, sorry. So I'm going to go 1310. What I wanted to do, it's okay. And then minus right there, here we go. That should work nice and pretty. And so I'm coming up with a negative 0.75. Okay, so negative 0.75. Let me pull this up here. I'm going to put that value in right here. So negative 0.75. We're going to check it. All right, we're doing great here. So now the next one we have is 2230. So we're going to do the same thing that we did before. So for part C, we have 2230. Okay. So Z equals 2230 minus 1544 all over 313. So again, I'll go second entry. Now I'm just going to change that first number to a 2230. Okay, hit enter now. And I'm coming up with 2.19. Yeah, 2.19. So again, when I pull up my problem again right here, I'm just going to type in 2.19. We're going to hit enter. All right. And I think we got one more to do, 1430. So let's go ahead and do it. So for part B, we're going to go 1430. There we go. All over 313. So let me pull up my calculator one more time. And let's come back over here. And let's go 1430. Okay, everything else stays the same. And I'm coming up with a negative 0.36. Okay, so now, right here, I type in negative 0.36. There we go. Okay, so it's asking me which are the ones that are going to be considered unusual. So let me see if I can pull this up here, you all. Let me do this. Oh, I know that looks weird. Okay, so I'm looking here at our Blackboard page, and so I'm going to click here on weekly activities, and here we go. So this here was from our review and test one, and I want to say, oh, maybe it's up there. Oh man, where is it? I thought it was here somewhere. Maybe it's in this part. Yeah, here we go. So here's my formula sheet from test number one. And if I pull this up here, you all, let me see if I have it. Here we go. This is what I'm looking at. So this part right here, I want to make sure that you guys can see that. Yeah, it looks like you can. This part right here, this is telling me where my unusual scores are going to be. So anything that's going to be between my Z values, if they're going to be between 2 and 3, they would be unusual. Same thing between -2 and -3, and then they would be very unusual if it was past 3 or smaller than -3. So when I come back to my actual problem, look, this one here would be considered unusual because it's past 2. You know what I mean? So right here, I would say the one that's unusual would be the 2.19. And I'm going to check my answer right there. Oh, one more. Okay, do we have any other one unusuals? Let me see. Let me go back to my little formula sheet. Maybe I'm missing something. So 2.19. I don't think I have any other ones. Where am I making a mistake? I'm making a mistake somewhere. Ah, I know why. It's not that the two. It's I know that the 2.19 is an unusual score, but what gave me that value, the 2230? That's my mistake. So the 2230, when we computed the z-score, we got a value that was more than 2. That's the one right there. Okay, so now we got it. Okay, so guys, originally I had put up another problem, and I think the one that I had put up was 15, and I actually want to do 15 because, Ivy, you were asking me about how do I know when to use like the positive 999, the negative 999, all that kind of stuff. So look, let me go to, I think it was 15 was the original one that I had come up with. Yes, this one here. So let me pull this problem and I'll put this in my notes and then we'll go ahead and go through this one together. So again, you can kind of see that where do I use the whole 999 business, okay? All right, so here it says, find the indicated probability using the standard normal distribution. Okay, so there's a couple of ways we can do it. The first one I'm going to show you is using the calculator. Okay, so this is what my normal curve looks like, something like this, right? And we know somewhere here in the middle is 0, and then we have 1, 2, and 3, and -1, -2, and -3. And what we're looking for is what's the probability that z is smaller than a -1.38. So this is the number that I'm really interested in. So if I think about on the graph, where would my -1.38 fall? It would probably be somewhere right about here. So there's my -1.38. And because it says less than, what we're looking for is we're looking for the area to the left. Okay, so since I'm trying to find the area to the left, and we keep going this way to the left forever, we're approaching the idea of negative infinity. Okay, and since we're approaching that idea, when we use the normal CDF on our calculator, we always have two numbers. There's a first number and a second number. This is what we call our lower limit, and this one here is what we call our upper limit. So my lower limit is going to be all the way over here to the left. And since we keep going all the way towards negative infinity, but remember, negative infinity or positive infinity is more of an idea than an actual number, then what I'm going to enter in right here would be my -999, okay? And then my upper limit means where do we stop? So I'm always going from the left to the right. I'm going to stop at my -1.38. So Ivy, am I making any sense in terms of how I'm trying to figure, like how I can figure out the -9999 or the positive 999? Because I'm using the idea of, I'm using the idea of my lower limit and my upper limit.
Yes. Can I
Yeah.
use the less than sign as a reference? Like, you know how the
Yes,
arrow
ma'am.
points to the left?
That Yes, you are absolutely correct. That's exactly what we're doing. So when we look at this less than, that tells me, hey, you know what? We were really looking for everything to the left, right? Because it's to the left of that -1.38, right? So now
Yes.
look, y'all, I'm going to pull up my calculator again, and I'm going to enter this in exactly like we have it on our paper. So we're going to go second, and then bars, and then we're going to go down to our normal CDF right here, and we're going to enter our lower limit, which is the -1, 2, 3, 4, comma, and then the -1.38. Oops, I forgot the one and the negative. -1.38. Here we go. Close that off. Hit enter. Oops. Right. Let me try it again. Second bars. Normal CDF. Here we go. -9999, comma, -1.38. Close it off. Hit enter. And there we go. So we're coming up with a 0.0838 because we're going to go to 4 decimal places. So 0.0838, 0.0838. And then what I'm going to do is I'm going to pull this up right here, and I'm going to type in a 0.0838. And I'm going to check my answer, and we got it, right? So look, let's just do one more, and then again, we can definitely move on to something from 4.2. But I want to just kind of just show you guys, again, drawing a picture, y'all, for me, is something that helps me every single time that I do these problems. So even though I teach this stuff, I still draw a picture every single time because it's going to help me figure out exactly what it is I'm trying to do. So like, again, first thing I do, I draw my normal curve. Looks something like this, right? I know there's 0, 1, 2, 3, -1, -2, -3. And we're looking for the probability that z is greater than a 0.15. So I say, look, right about here is my 0.15. And because we are going to the right, we're now interested in the area going this way, right? So again, we're going to approach the idea of infinity. And so when we do this on our calculator with our normal CDF, right? And we said we have two numbers. We have a lower limit and we have an upper limit. And so we're going to say our lower limit is the 0.15, but because we're going all the way to the right, we're going to have that idea of infinity. So on the calculator, we'll just use the positive point or the positive 999, right? So again, I'll do this the same way. I'll go second, vars, and I'll use my normal CDF, and we're going to start at 0.15, and we're going to go all the way to the nines. And the number that I'm coming up with is a 0.4404. So 0.4404, because again, I am going to 4 decimal places. And since that number to the right of the 3 is an 8, I need to bounce it up. And so right here, I'm going to type in 0.4404, and we're going to check our answer, and we got it. So let's see. Guys, should we go ahead and try something out of 5.2? Since we did a couple of problems here from 5.1?
Yes.
Are you guys? Yeah, we're good. Okay, so let me look. Is there any, guys, but as I'm going to go to 5.2, are there any questions in particular that you all want me to answer out of 5.2? I mean, I can pick one, but if there's one in particular that you'd like for me to do, let me know. I'll tell you what, last time it looks like we did 2 and 4.
I have a question about 5.2.
Okay.
When we have to subtract the 1.
Okay, when do we subtract the 1? Okay, let me see if I can find one like that where we have to subtract.
Question 1 is like that.
I'm sorry?
Question 1, I had to subtract 1.
Yeah, I'm trying to see if there's one like that in 5.2. I'm trying to see if I can find one like that. Let me see.
I subtracted 1 is number 1.
Okay, let's take a look at number 1. So here's number 1. Okay, so I'll tell you what I'm going to do. I'm going to go ahead and do a little copy and paste here. But I don't think I need to do the whole subtracting 1 here. I mean, we could, but I don't think we need to do it that way. But let's try number 1. So here's number 1. Let me see. Let me zoom in a little bit so we can see it a little better. Okay, so it says, assume the random variable x is normally distributed with a mean of 87 and a standard deviation of 4. Find the indicated probability. Okay, so first thing we're going to do, y'all, we're going to take this x value of 85 and we're going to convert it, 85. We're going to convert it to a z-score. So remember, we're going to go x minus mu over sigma. So we're going to take x, which is 85, minus our population mean, which is 87. Again, y'all, when I'm doing this on my calculator, I'm always going to put this part here in parentheses, divided by my standard deviation. So let's go parentheses 85 minus 87 divided by 4, and we're coming up with a negative 0.5. Okay, so now all we're going to do is we're going to change this piece here. Instead of us writing it, what's the probability that x is smaller than 85? We're going to say, what's the probability that z is smaller than a negative 0.5? And this problem right here is just kind of like the one that we did out of 5.1. So I'm going to draw my normal curve again, like this. I'm going to put 0, 1, 2, 3, and -1, -2, and -3. And the number that we're really interested in is this number right here, which is a negative 0.5. And because this is telling to the left, then remember what we're looking for. We're looking for the area to the left of that curve, right? And so just like we did earlier, remember, we're approaching the idea of negative infinity over here, positive infinity would be that way. But when I use my calculator, and I'm going to find my normal CDF, remember, we have two numbers. One of them is the lower number, and the second one is the upper number. And since I'm all the way over here to the left, I'm going to use my negative 9999, and then I stop at a negative 0.5. And so again, we'll just do this just like we did earlier. So we'll go second bars, we'll scroll down to our normal CDF, we'll use a negative 9999, comma, a negative 0.5, and we'll hit enter right here, and we're coming up with a 0.3085. So 0.3085 for our answer. And so when I come back to this problem here, let's see, 0.3085, here we go, 0.3085, and we're going to check it, and we got it. I think the stuff that had where you had to subtract 1, I want to say that we did some of that more in chapter 4, but I don't know we had to do some of that in chapter 5. I mean, there's times when you can do it. So like, look, let's try this one here, and I'll show you 2 ways of going about doing it. And I'm going to just hit similar questions so it gives me a new problem to do. Here we go. And you know, I'm sorry, go ahead.
I think
So
what happened with, oh, sorry.
No, you're okay. The way that you know then how to use the 999 is whichever direction it's going.
Yes, ma'am. That's
Okay.
exactly right. So
I'm sorry,
yeah, look,
that's like silly, like.
No. Guys, there's no, like I said before, somebody told me that in our class, and I said, like, there's no silly questions. I really want to make sure that y'all have an idea how to do this. So that's why I said, like, every single time I'm going to draw my picture. And think about it this way, if my arrow is pointing to the left, then we're going to use our negative 99999, right? And then let me scroll down a little bit here. And like the way we did this one, since our arrow was pointing to the right, then we used the positive 99999, right? And so really all it is just looking at the direction of the arrow that you're given, right? And so the only difference between, like, say, this problem here and this one here was, in this problem, we had to do a little bit of work to get the z value, but then once we get this, we're going to do it just like we've been doing the others. Does that make sense on how to do that and how to come up with whether I'm using the negative 999 or the positive?
Yes.
Yeah. Okay. So let me ask y'all a question. Do you want me to go through this one here as well, or do you want me to find a different problem, or do you want me to just to go into 5.3? I just, I'll do the problem if we need to, but I also want to make sure that I'm able to answer all the questions that you guys have.
The one that has the less than 67 and then between.
Yes.
Two
Okay. So the
numbers.
one that has the between, right? Okay. So let me go like this one right here. Yeah. Let's do this one because I agree. Sometimes these here can be just a little tricky as well, but we will definitely do this one here. So let me copy this one, and then I'm going to paste it here in my notes. So let's go like this. And I'm glad you guys joined today, y'all. This is good. I want to make sure, like I said, that you guys feel okay about this, and that, when we leave the session today, you're like, oh, you know what? I can do this. It's not as hard as I thought it was going to be. Okay. So this is what we're going to do. When we look at this problem, it's not just less than a number. The x is between these two numbers. Okay, so what we're going to do, we're going to find two z-scores. So I'm going to call it z1. And we're going to still use our formula we've been using so far. And the first time we're going to do this, we're going to do it with 70. So we're going to say z1 is 70 minus mu, which in our case is 83, divided by 4. Again, y'all, on my calculator, I'm always going to put that part there in parentheses because if I don't, then what it does is it takes 83 and divides it by 4, and it subtracts that number from 70. So I got to do 70 minus 83 and then divide everything by 4. Okay. And so I'm coming up with a negative 3.25. Okay. And then we're going to do the same thing. I'm going to call it Z2, but now I'm going to use this number. So I'm going to go 80 minus 83 divided by 4. Okay. So I'll do the same thing, second entry, and I'm just going to change that 70 to an 80. And a negative 0.75. Okay, so now that we've done that part, what we're going to do now, we're going to rewrite our problem. And this was the first number we got, so a negative 3.25 is smaller than, we're not using x anymore, we're using z because that's what we converted these things to, negative 0.75. Okay, let me write it again so it looks a little bit cleaner. Like this, z negative 0.75. Okay, so that's what we have now. So just like we did before, y'all, I'm going to draw my picture. Looks something like this, right? Here's 0, 1, 2, 3, minus 1, minus 2, minus 3. And the two numbers that we want to place on here are this one, negative 3.25, which is all the way over here, and negative 0.75, which is right about here. Okay. And what we're trying to find is we're trying to find the area in between those two values. Okay. So remember how we said we're going to do this. And again, y'all, I'm showing you on the calculator just because, again, the tables work, but the tables are also a little bit more work in terms of how to do this stuff here. Okay. And like I said, some people like the table. I like the table sometimes when, if I'm going to do just a simple problem, but as the problems get more complex, I'm definitely going to want to use my calculator. So remember, we have a lower limit and we have an upper limit. So we notice what our lower limit is. We start at negative 3.25 and we stop at negative 0.75. And like I said before, y'all, to me, what helps me the most is drawing the picture, because when I draw the picture and I put those two numbers on there and I do my shading, I can see exactly what it is I'm looking at, right? And then because, I don't know about you all, but I feel like I'm a visual learner. If I can see what's happening, it usually makes it a little bit easier for me. But once I see it, then I'm able to say, okay, look, let's come back. Let's take our calculator. We're going to go second bars. We're going to go to normal CDF. Our lower limit is a negative 3.25, comma, and our upper limit is a negative 0.75. And then we're going to hit enter, and I'm coming up with 0.2261. So 0.2261 is what I'm coming up with my answer, because if you notice, the number to the right of the 0 is a 5, so that 5 is going to change that 0 to a 1. And so now what I'll do is right here, I'm going to type in 0.2261. And again, it's always telling me to go to 4 decimal places, so we do, and we got it. But, excuse me, excuse me. So, but let me ask you all a question. Do y'all find like the picture is helping you guys as I'm drawing it out? Okay. I heard something in the chat. Let me come back. Let me see if I can find it. Where are we? I know that looks really weird.
Yes.
Okay, good. Good, yeah. So yeah, y'all, the picture is like super, super helpful in me trying to figure out how to do these problems here. Okay, so that was a problem out of 5.2. Do you want me to do any more out of 5.2? Do you want me to jump to 5.3? What do you all think? Do you want me to do one like this?
Can you do one more? Yes. There's one, I don't remember if it's the age one, that you even did a video on it. I want to say there's 2 videos. I watched both videos and I still I don't know. I don't absorb it or something.
Is it this one right here? The man and the heights of the
Yes.
age? Okay.
Yeah,
Yeah,
you
let's definitely.
explained it. I watched it and I still can't do it myself.
Yeah. No. Let's definitely go through this one. And I'll tell you what, y'all. Once we go through this one, let's see if we can get something out of 5.3, just so that we can make sure that we can, get to all the questions today. But no, we definitely got time to do this one. So look, let me pull this one up here. Here we go. Okay, so it says in a survey of a group of men, the heights in the 20 to 29 age group were normally distributed with a mean of 68.8 and a standard deviation of 4.0. Okay, so the first thing I'm going to do here, I'm going to write my mean is 68.8 and my standard deviation is 4. So this is what we know so far. Okay, so now, look, let's take a look at part A. It says find the probability that a participant has a height that's less than 65. Okay, so what we're going to do here, we're going to say, what's the probability that the random person that we choose has a height that's less than 65? So what we want to do here, y'all, we want to convert this to a probability where we can say Z is less than something else. Okay, so the way we're going to do this is we're going to use our X minus mu over sigma. So our X in this case, y'all, is the 65 minus the 68.8. Remember, that's going to go in parentheses, and we're going to divide that by 4. Okay. So again, I'm going to take my calculator, and I'm going to go, what's 65 minus 68.8? Let's close that off. Let's divide it by 4, and we're coming up with a negative 0.95. Okay, so negative 0.95. So that's the number that I'm going to have right here. Okay. Now, remember how we did this part. When we're trying to find this part right here, what we say is, look, let's just draw a real simple picture. It looks something like that. It doesn't have to be perfect, right? And -1 and -2 and -3. And the number that I want to label is at negative 0.95, somewhere right about here. Okay. And because it's to the left, we're going to shade this way, right? So remember, there's my negative infinity, here's my positive infinity. So again, using my normal CDF, we're going to say, since we're all the way this way, we're going to use that negative 9999, comma, and then we're going to stop at a negative 0.95. So we're going to take this thing right here, we're going to go second in bars, normal CDF right there, and we're going to say negative 9999, comma, negative 0.95, and we're going to come up with a 0.1711, yeah. So 0.1711 is what I'm coming up with for part A. So let me pull this up right here so we can see it. So 0.1711. Still going to 4 decimal places. We're going to check our answer. All right, we got that part. Now let's do the second part. So let me copy and paste this piece here, y'all. So here we go. Get rid of that. Let's copy this. Let me pull this up over here in our notes. Right here. Boom. Okie dokie artichokes. Okay, so now it says find the probability that a study participant has a height between 65 and 72. Okay, so what that's telling me is that the height is between 65 and 72. So notice, y'all, my X is between those two numbers, right? So just like we did before, y'all, remember I said, we're going to use our formula Z equals X bar minus mu over sigma. And we knew that our mu was, I already forgot, I'm going to write it down again, 68.8. And our sigma was 4. And I said, look, we're going to have to do this twice. So we're going to have like a Z1 and we're going to have a Z2. And so Z1 is going to be when we take 65 minus 68.8, and we divide it by 4. And Z2 is going to be when we take 72 minus 68.8 and divide it by 4. But I think, if I'm not mistaken, we just did this in part A. So yeah, look, we did that already in part A, and we came up with a negative 0.95. So we already know this answer here is a negative 0.95. Let's find this one. So parentheses 72 minus 68.8 divided by 4. And I'm coming up with a positive 0.8. Okay. So y'all, just like we did before, what we're going to do now is we're going to, instead of writing it like this, we're going to write it using z values, right? So we're going to say, what's the probability that z is between, z is between negative 0.95 and a positive 0.8, right? So I ought to say, look, what would my picture look like? It would look something like this. And my negative 0.95 is still right about here. And my positive 0.8 is right about there. And we're looking for the area in the middle because z is between those two values. So when we do this using our calculator and we say, look, we're going to bust out the normal CDF, right? And remember, we have two numbers, our lower limit and our upper limit. And our lower limit would be the negative 0.95, and our upper limit would be the positive 0.8, right? So we'll do that here. We'll go second in vars. And we'll scroll down to our normal CDF. And we're going to go negative 0.95, comma, 0.8. There we go. And the number I'm coming up with is a 0.6171. So 0.6171 is what I'm coming up with. And so I'm going to type that in right here. And let's see if we can get this to work. Here we go. 0.6171. And we're going to check our answer, and we got it. Awesome. We are all doing great. And then we got a part C here, y'all. So let's do part C, and let's see what we can't figure out. And we're doing that. Let's copy this here. And let me zoom out just a little bit again. And paste it. Here we go. Okay. All right. So it says, find the probability that a study participant has a height that's more than 72. So remember what we're trying to find here. What's the probability that X is greater than 72? And again, what we want to do is we want to convert that to a z-score. But again, we just did that in part B, right? We did it right here. Remember, we came up with a positive 0.8. So this number here is a positive 0.8. So again, when I draw my picture, right, and here's my 0, my 1, my 2, my 3, and -1, -2, and -3. The number I'm interested in is that positive 0.8. And I'm shading everything to the right. So again, one more time, y'all, when we use our normal CDF. Anybody know what my lower limit is now? Now that we've done a few of them? Anybody know what's the first number I'm going to use right here? And my second number?
You're going to use the 0.8, and then you're going to do the 9999 is the upper.
You got it. Take it away. Very good. Perfect. I could have stayed home today, guys. That's what I used to say when we used to be in class. You already know what to do. 0.8, comma, but I'm already home right now. And one more 9. And guys, just to give you a heads up, you know, whether you put 3 9s, 4 9s, 5 9s, it doesn't really make a difference. Just don't put like 1. You know, I would definitely say at least put 3. All right. And 0.2119, 0.2119 is what I'm coming up with. So right here, y'all, I'm going to put 0.2119. We're going to check it, and we got it. And let's see. Okay, so do we have any unusuals? So remember, it's telling me right here, y'all, it's going to be unusual anytime the probability is less than 0.05. So like that's not smaller than 0.05. Neither is that one, neither is that one. So we don't have any unusual events. So I would say there are no unusual events, but if any of those numbers were smaller than 0.05, then I would have to select that. Okay, so we'll check our answer, and we got it. Okay, good, good, good. So let me get rid of this part here, y'all, and let's go through something from 5.3. So I'll tell you what, I'm going to pull up 5.3 here, and I'm going to ask you all if there's a particular question that you would like for me to do, and if there is, we can do it, and if you just want me to pick one at random, I'm happy to pick one at random.
11.
11. Let's do number 11. So let's come back over here. Let's get number 11, and let's see if we can't figure this out. Okay, so let me copy and paste this one here. And actually, hold on, let me try this. Oops. I'll try to make it a little bit smaller like that, so when I copy and paste, it's a little easier. All right. So yes, let's do number 11. Let me paste this in here for us. Okay. All right, so it says, in a survey of women in a certain country, ages 20 to 29, the mean height was 66.3 inches with a standard deviation of 2.75. Answer the following questions about the normal distribution. What height represents the 95th percentile, and what height represents the first quartile? Okay, so we know this already. We know that our U is 66.3. And we know that our standard deviation here, y'all, was 2.75. Okay, and what we're trying to figure out is what are the heights at the 95th percentile and the first quartile. Okay, so what we're looking for here, we're actually looking for the x value. Okay, and so if you think about what's going on here, and again, I'm going to draw my picture just so we can kind of see what's going on, right? Okay, here's 0, 1, 2, 3, and -1, -2, -3. Okay, the 95th percentile, what that means is that we're looking for a value somewhere over here. I don't know if it's between 2 and 3, if it's between 1 and 2, or if it's more than 3. We're looking for a value so that the area underneath this curve is 95% or 0.95. Remember the total area, y'all. Oops. The total area is equal to 1. Okay, so the way I'm going to do this part here is a couple of ways I can do it. I want to show you one way. So it says, look, here's some tables here, right? We can look at the tables. So actually what I'm going to do, I'm going to pull up this particular problem again so I can show you how you could do it if you wanted to use the table. I'm going to tell you right now, since I'm looking at 0.95, I'm going to go to page 2. Okay, and I think you guys can still see this. Let me see if this is still working for you guys. Sorry. Yeah, it looks like you can. Okay, so I'm going to look for something, a number in here, somewhere in here that's like close to 0.95. So 95, I'm kind of, okay, right here. Do you see these two numbers right here? One of them is 0.9495 and the other one is 0.9505. So wouldn't 0.95 be right between those two numbers? And so if this is 1.6, this would be 1.64 and this would be 1.65. So the number that I would probably be using if I was using my table would be something like 1.645, because that would be the number that would be kind of like right in the middle between those two right there. Okay. So again, I'm going to show you two ways. I'm going to show you one way using the table, then we'll come back and use our calculator. Okay. So using the table, the number that I came up with was 1.645. So right here, the number that we got, I used a little bit too much of this, 1.645, somewhere right about here. Okay, so the number we have, 1.645. Okay, so the way we had our z-score, it looks something like this over sigma. So there's a way that we write the x value. And the way we write the x value is we take z times sigma and we add mu to this. Okay, so I'm going to say, look, x is going to be equal to z, which was 1.645 times our sigma. And our sigma in this problem was a 2.75. Plus our value of mu, and our mu value was 66.3. Okay, so I'm going to do this on my calculator. I'm going to say turn it on first, clear it, 1.645 times 2.75 equals, and then I'm going to add the 66.3, and I'm coming up with 70.82. I'm going to see what it wants me to round to. I'm going to say 70.8 because I think it's probably going to ask me to round to one decimal place, but let me just double check. 2 decimal places. So let me come back. 70.82. Okay. So the one way we could do it was by using our table, right? And we say, you know what? I don't want to use the table. I want to use my calculator. How would I do that? I'm still trying to find this z value right here. So on my calculator, y'all, the way I'm going to do this, I'm going to clear everything out. I'm going to go second bars. I'm going to go to inverse norm. What inverse norm is going to tell me is what is the z value if I know the area under the curve. And we know the area under the curve. The area under the curve was 95% or 0.95. And notice the number that we got here, 1.644. So if I were to go to, say, to 3 decimal places, I would use 1.645. And that's how I would come up with that same number right there. Right? And then the rest of it would still be the same way. So if you wanted to use the calculator, y'all, let me just write this down here so you can see it. Move it over here just so we have some extra room. So if you want to do this using your calculator, we're going to go inverse norm. And the number that we put in here is the area under the curve. Okay. So like in our case, we typed in 0.95. Okay. And again, if you notice, the number we came up with was 70.82. So look, y'all, I'm going to come back over here. Let me get rid of this. And right here, I'm going to type in 70.82. And we're going to check it, and we got it, right? And then now let's do the same thing for part B. So now part B says, what about the first quartile? And this one here, y'all, I'll show you just directly using the calculator so that we don't have to pull up the table. But again, if you want to use the table, you can. But like I said, I think for the most part, the calculator is usually what a lot of people kind of like. So let me do this. Here we go. Okay. What's the height that represents the first quartile? Okay, so what does that mean? What does the first quartile mean? So I'm going to draw a picture. It looks like this. 0, 1, 2, 3, minus 1, minus 2, minus 3. Think of the idea of quartile, like quarters. Quarters is 25%. So there's a value that's going to be somewhere over here in the first quartile where the area underneath that curve is 0.25. That's why we're talking about the quartile. So again, the way I'm going to do this, y'all, I'm going to go inverse norm. Remember, the number that I have here is the area under the curve. And the number that we have is 0.25. So I'm going to go second bars, inverse norm, one more. Here we go. I'm going to go 0.25. I'm going to hit enter. And I'm coming up with a negative 0.67. Okay, so that's telling me my z value is a negative 0.67. Now, there's a formula. The way we find the x value is we're going to take z times sigma, and we're going to add mu to it. Okay? So we're going to take negative 0.67 times our sigma. So I'm going to scroll back so we can figure out what our sigma was. Our sigma was a 2.75 and our mu was a 66.3. Already forgot. 2 point something? 2.75 and 66.3. All right. So we're going to take, let me clear this out, negative 0.67 times 2.75. See what we get. We're going to add that to 66.3. And I think we're still going to 2 decimal places. So I would say 64.46. 64.46 would be the answer that I would come up with. And then right here, y'all, I would type in 66.46. Because that, or 64.46. Oops. 64.46. And we check it, and we got it. What do you think? Does that make sense for number 11 on how I'm able to figure it out?
I feel like I feel more confident when you like hold our hand through the problems, but
Yeah.
when I open it up and it's like, I don't know, it just, and it takes me forever to figure out, like, you know, a lot of times when I'm doing the homework, I have
Uh-huh.
to get it wrong to realize what I was doing wrong.
Okay.
Because then when I see the
Okay.
correct answer, then I'm like, oh, okay, I get it.
Yeah, I know. I mean, look, guys, I'm not gonna lie. I think this would definitely be a lot easier if we were like, if we saw each other twice a week and we were on campus and all that kind of stuff. I definitely think it would be a lot easier if we were like that. I think there's some classes where, and then everybody's different. You know what I mean? Like some people can do this. Some people can like watch the YouTube videos and they're like, oh, I understand perfectly what he was doing, or I got lost a little bit, but then I went back and rewatched it. It worked. And then, excuse me. And then other people are like, yeah, I really need to kind of see more of it, multiple times or whatever. One thing I really want to emphasize, y'all, and you know that I sent out a problem earlier today. Anytime you guys have questions or if you're doing this and you get stuck, don't hesitate. It doesn't matter when you guys message me. So I don't know if I told this to you all or not, but like my Pronto app, y'all, I keep it on my iPad, okay, and I don't take my iPad into my bedroom at all. It stays here, kind of like in my home office. So, if you're working and then I have like, office hours or whatever. So like once my office hours are done, I leave my iPad in the office and I'm either, hanging out in the living room with family or in the bedroom or whatever happens to be, or out, outside or whatever. But don't hesitate to message me. Like, don't ever worry like, oh, if I message him at 3 in the morning, am I going to wake him up? You're not. Okay. Because the iPad always stays in the home office. So don't worry about, messaging me at any time of day. And then when I do my office hours and I'm going through the stuff, usually what I do is I come over here to the home office and I start making little videos. Like, I know I sent one out this morning for our class, and I sent out a couple other ones for some of my other classes. So, yeah, I understand exactly what you're going through. So I'll tell you what, y'all, let's go through a problem from 5.4. I know we're running a little bit short on time, but I do want to make sure I answer something from you guys out of 5.4. So let me pull something here out of 5.4. Y'all only had 8 questions, but I want to make sure that we're able to answer any of the questions that you guys have. So,
Sir, I feel like what
excuse me,
confused
I'm
me the
sorry?
most. What confused me the most was when you would show us how to do it with the graph, and then you would show us how to do it with the calculator. So that's when
Yeah,
I would find myself confused because if I like to stick to the calculator because it's
yeah,
more precise. So like I would get the hang of it, and then you would like do it the other way, and I would just get lost again. So
yeah.
that's
And the only reason I did that, y'all, so like, I'll put it this way. At the end of this semester, I'm going to have 24 years that I've been teaching, right? But I just started teaching stats like right before the pandemic hit. Like I taught stats for the first time in the fall of 19. And when I taught that class, the class was in the evening. It was a night class. And like, I'm trying to think who's here. So I know Christine, you're here. Ivy, I think you're here. I don't know if Eric is still here. Eric is still here. Yes. And And Ivy, I saw that you had your hand up. I'm just seeing that right now. Do you still? Is there anything you wanted to tell me before I keep going?
No, it was that what I
Oh,
said.
okay. Okay. Yeah. So I just saw that you had your hand up right now. So, when I taught that class, y'all, in the fall of 19, I taught it at night. And like Christine, Ivy, Eric, I don't know how old you all are, but I'm 48, right? So this was 2 years ago. I was 46, and I had a lot of students in that class. They were like my age, you know, maybe I would say they were like between 35 and 45, something like that. I know there was one woman there who was slightly older than I was. But because I have like a more mature group or an older group, like a lot of those students, they were just not really comfortable using the calculator, right? So we would use the table a lot because that's just something that they were more comfortable with that. Like I don't know when you guys got out of high school, but I'm guessing when you were in high school, I'm guessing you all had some experience with maybe one of these. But if somebody is say 40 years old, they've been out of high school, 22 years, they may not have had that same experience, right? So they were just more comfortable. A lot of them were more comfortable using the table, and then as we went through, some of them uh, were more about, like, hey, yeah, I'm kind of getting used to the calculator, but that was kind of one of the reasons. And then since we're like in an online class, we don't get to see each other. So I don't know if I have anybody in my class that isn't really comfortable using a calculator and they're more comfortable using like the table. So that's kind of why I do both. But really what I want to say is if you find one that works for you, like if you find the calculator works for you every time, by all means, y'all use the calculator every single time. I know I've said it a bunch of times, like, hey, the calculator is going to be like your best friend in doing these problems. So anyway, let's see. We still got a little bit of time. Well, we're out of time, but we're still gonna do something here from 5.4. Are there any problems that you want me to do? Like, you want me to do this one here? This, like, instead of like say, oh man, my mouse is freezing up. Why is it freezing up on me? I don't know. I'll just use this part here. So like, instead of me doing something like this, right, which is just kind of real plain Jane, would you guys prefer for me to do something like this, where it's in the context of like a word problem?
Can we do 4?
Yeah, we can definitely do 4. Okay, so let me do number 4. I'm trying to see why hold on, my mouse is just kind of freezing up a little bit. Let me try this one more time. There we go. It's working again. Okay, so let's do number 4. And so I'm going to copy and paste. So let's go like this. Okay, so y'all, the main difference in like 5.1, 2, and 3 compared to 5.4 is that like in all these problems, like the one that we just did, like this last part we just did, we were looking like the two values we came up with were 78 or 70.82 and 64.6. So these were like for specific, like a specific height, right? Like there's one person who their height is 70.82 inches, something like that, right? So let me pull up this problem again. This is the number 4 from 5.4. And it says the population mean or standard deviation are given below. Find the required probability and determine whether the given sample mean would be considered unusual. So it says from a sample of n equals 65, find the probability of a sample mean being greater than 225 if our population mean is 224 and our population standard deviation is 57. So the main difference in like 5.1, 5.2, and 5.3 is in those problems where like we picked a person, right? Remember the one, I'm just going to kind of come back real quick here. Remember when we did this problem here about the men and their height, and it was like, what was the probability that a participant, so one person had a height that was less than 65? That's the kind of stuff we're doing in 5.1, 5.2, and 5.3. What we're doing in 5.4 is we're saying, you know what? Instead of taking one person, we took 65 people and we took the average of their heights or whatever it happened to be. And that's kind of what we're doing here. Okay. So look, when I look at this part right here, it says find the probability of a sample mean being greater than 225. So what does that mean? It means that the probability of X is greater than 225. So again, just like we did before, y'all, we're going to convert that to a z-score. There's only a couple of things that are different. So number one, my mu is 224, and my sigma is 5.7, and we know that our n in this case was 65. Okay, so the way we're going to find the z-score, it's going to be similar to what we did before. It's going to be x minus mu, but it's over sigma divided by the square root of n. That's the only part that's really different here. So look what we're going to do. We're going to take our x value, which was 225. So again, remember, y'all, I'm going to do this in parentheses, minus 224 divided by our sigma, which was 5.7, divided by the square root of this number. Okay, so the way I wrote it here, y'all, with my parentheses is the exactly same way I'm going to write it in my calculator. So let me turn this on. Let me clear all this out. So I'm going to go parentheses 225 minus 224 divided by, and I'm going to put parentheses again, 5.7 divided by the square root of, what was it, 65? Notice on my calculator, y'all, when I did my square root, it opened up parentheses for that. So I need to close those off, and then I need to close the bottom parentheses. The one that I opened up in front of the 5.7, this one here is closing that off. And so the z value that I'm coming up with is 1.41. So right here, I'm going to put 1.41. Everything else, y'all, is going to be exactly the same way we've been doing it. This part right here that I just circled, we're going to do it exactly the same way. So what I'm going to do now is I'm going to draw my picture. 0, 1, 2, 3, minus 1, minus 2, minus 3. 1.41 somewhere right about here. And I'm shading everything to the right. So I bet you guys, I don't even have to tell you what you're going to do, right? I bet you at this point, you know you're going to go normal CDF. And would you say that you're going to go 1.41 comma 9999 just by looking at the picture?
Yes.
And if I were to go second bars, normal CDF, 1.41 comma, and then a whole bunch of nines, and hit enter, and I'm coming up with 0.0793. 0.0793, right? So if I were to come back over here, 0.0793, and we're going to check it, and we got it. And okay, would the given sample mean be considered unusual? So let me come back again one more time. So look what we came up with. We came up with 1.41, right? And so look, y'all, I'm going to share something with you guys here. I know that looks weird. Remember here were my unusual scores. So in order for it to be unusual, it would have to be more than two, like it would have to be between 2 and 3 or more than 3, something like that. My z-score would have to be more than 2 or more than 3 deviations away, right? So if I come back here, I would say the sample mean would not be considered unusual because it does not lie, or it lies within the range of an unusual event, namely within, let's see, 1 standard deviation of the sample mean. So let me double check my answer. Oh, something isn't right there. Okay, let me double check.
Because it's 2 standard deviations because it's
2. That's right. 2. There we go. So we check it, and there we go. We got it. So there we go. What do you guys think? I mean, do you see, like, really the only difference, y'all, in when I was doing this problem out of 5.4, the only part that was really different from anything else was how we did our z-score, and it was because of that part right there. And so really the only difference here is instead of saying like, oh, we picked one person, we didn't pick one people. We took 65 people, and we found and we said, what's the probability that their average is greater than 225? So instead of saying, let's pick one person, we're saying, what happens if we took a group of 65 people, found their average, and what would be the probability that that average is greater than 225? But the process is still the same. The only thing that's different is how we compute our z-score. Are you guys feeling a little bit better about the stuff here in chapter 5? Anybody? Let me
Yeah.
that part. Yeah, a little bit better.
I
Okay.
had the most trouble with 5.4, I think.
Okay, I'll tell you what. You want me to go? You want me to do one more problem out of 5.4?
Yeah.
Yeah, if
Me
you
too.
can, that would be awesome.
Yeah, definitely. So which one do you guys want me to do? So we just did number 4. Let me pull up the screen
I
again.
think
Real
all
quick.
of them are similar. They're all very similar.
Yeah, they're all definitely very similar. Let me pull this up again real quick. Okay, so we just did number. Let's see.
Number 7 is a little different.
Okay, let's take a look here. So let's keep going. Number 7. Okay, so it says the heights of women in the age 20 to 29 is normally distributed with a mean of 63.9. Assume sigma is 2.4. Are you more likely to select? Oh yeah, definitely. Okay, so look, I'll tell you what. Let's definitely do this one here. This is a good problem for us to do.
Yeah.
Yeah, yeah. This is definitely a good one. Okay, so let me paste this in here, y'all. And okay, let's see. Here we go. And I'm just going to make sure you guys can. Oops. Yeah, I think you guys can see it now. Yeah, we're good. Okay, so it says the height of women ages 20 to 29 is normally distributed with a mean of 63.9 and a standard deviation of 2.4. Okay, so look, we know that our population mean is 63.9 and our sigma is 2.4. It says, are you more likely to select one woman with a height of less than 65.6, or are you more likely to select a sample of 20 women with a mean height less of 65.6? Explain. Okay, so to do the first part, this is what we're going to be, this part here is basically what we did from 5.1, 5.2, and 5.3. So look, we're going to say, what's the probability that X is less than 65.6? So we're going to use our z-score, right? We're going to say, look, X minus mu over sigma, just like we did 5.1, 5.2, and 5.3. And so we're going to say our X value is 65.6 minus our mu, which is 63.9, all over the 2.4. Okay, so let me grab my calculator here. Let me turn it on, clear it out. So we're going to say 65.6 minus 63.9, and we're going to divide that by 2.4. And I'm coming up with, I'm going to go to 2 decimal places, y'all, because with the z-score, we always go to 2 decimal places. So I'm going to say this is a 0.71. Okay. So notice what I'm going to do here, y'all. I'm going to change this from an X to a Z. What's the probability that Z is smaller than 0.71? Okay. And so I'm going to use my calculator. I'm going to draw a picture first. Here's my 0, 1, 2, 3, minus 1, minus 2, minus 3. 0.71 is right about here. And we are finding the area to the left, right? Anybody know what my what my lower and upper limits are going to be?
The negative
999.
999.
Hey, I could have stayed home, y'all. You already know what to do. Negative 9999 and the 0.71, right? Good. We all got the hang of this already. This is great. Oops. Normal CDF, negative 1234, comma 0.71. Let's go like that. And so I'm coming up with 0.7611. So 0.7611. So right here, excuse me, I'm going to type in 0.7611. We're going to check our answer. Perfect. And now there is a part B to it. So let's see how we're going to do part B. Let me copy and paste this part into our notes. Okay. Okay, so it says, what's the probability of selecting a sample of 20 women with a mean less height of 65.6? Okay, so a couple of things we need to know. We need to know what our mu was. So I'm just going to go back and figure out what those numbers were. Mu was 63.9 and sigma was 2.4. Okay, so 63.9 and sigma was 2.4. Okay, now we have a sample of n of 20 women. So my n here is 20. So what we're trying to figure out now is what's the probability that x is less than 20? But again, we don't. It's not one person. It's a sample of 20 women, right? So when we're going to find our z-score, y'all, we're going to say, look, z equals x minus mu, and this is divided by sigma and the square root of n. Okay. So I'm going to say x, which was, I'm sorry, it wasn't 20. Sorry. My x value was 65.6. Okay. So 65.6 minus our mu, which was 63.9, divided by 2.4 over the square root of 20. So again, I'm going to do this on my calculator as well. So parentheses 65.6 minus 63.9 divided by parentheses 2.4, excuse me, divided by the square root of 20. Again, I got to close those parentheses. And so the z value I'm coming up with is 3.17. Okay, that's the number that I came up with for z. So right here, y'all, I'm going to put 3.17. So I'm going to draw my picture, right? 0, 1, 2, 3, minus 1, minus 2, minus 3. 3.17 is going to be somewhere over here. Okay. And so again, doing this on my calculator, let me make sure I'm doing that right. Sometimes I'm always just a little concerned that I didn't enter something correctly, but it looks like we did. Okay, so yeah, we got 3.17. Okay, so again, y'all, on my calculator, I'm going to go normal, CDF, and negative 9999, and oops, 3.17 was over here. Sorry about that. No, that's why I was getting a little confused. It's a positive 3.17. There we go. That looks better. Okay, so let's do this on our calculator. Second bars, normal CDF, negative 9999, comma, 3.17. And we should be coming up with a pretty big number. Yeah, 0.9920 or 0.992. So 0.9992 is what I'm coming up with. So right here, we'll go 0.9992. Right, excellent. Okay, so which one is greater? Obviously the sample of 20, right? So we're going to say it's more likely to select a sample of 20 women in the mean height because the sample of 20 has a higher probability. Yes, it does, right? So then I'll check my answer here, and we got it. And y'all, just real quick, if you look at the two pictures, so remember the first time I drew this, I didn't draw this as great, and that's when I realized, like, hey, something doesn't look good here. So here's my 317. So I'm really shading everything this way compared to this one here, right? So you say which one has a greater probability? This one does, because just by looking at the picture, we've shaded more than we did in, say, this one over here, right? Alrighty. So what do you guys think? Y'all feel a little bit better about 5.1, 5.2, 5.3? A little bit better about some of this stuff here?
Yes, I do.
Yeah.
Yes, sir.
Okay. Awesome. Good. 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 All right. So, like I said, y'all, just a reminder, y'all, 51525354 is due by tonight. I am going to log off for the rest of the day, but just take your time. You can go back and rewatch some of the stuff. But like I said, y'all, anytime you have questions, don't hesitate to ask me. I'm happy to help. Let me stop recording this already. And